Hello everyone. In this tutorial, I am going to demonstrate you how to prepare solutions with different concentrations and how to fill up the laboratory manual during the actual practical sessions for the lab Physical Pharmacy 1. You know that in the Physical Pharmacy 1 lab, you have to prepare different types of solutions for almost every lab, and you have to write down the calculations for the preparation of reagents and the reagent. And the calculation may require solid reagents as well as liquid reagents. So in this tutorial, I am going to show you how you should prepare the reagent and how you have to fill up this laboratory manual during the actual laboratory session. Okay, now let's move on the preparation of solution using solid reagent as well as liquid reagent. Okay, in the laboratory manual, you will find a problem. The problem will have this types of line. How would you prepare? There is a gap, ml, there is a gap, molar oblique normal, there is a gap, solution using method 1 and method 2. This, I must say that I am showing the preparation of solid and liquid reagents for the experiment number 1. In the experiment number 1, you have to prepare the solution in using two method 1 and method 2. That is why the method 1 and method 2 has been indicated in the question. Okay. So the question is, sorry for that. So at first you have to fill up the question. Whenever you asked to prepare a solution with a specific volume and a specific strength, and you know the name of the reagent that have to be prepared, then you have to at first you have to fill up this question form. Suppose you are asked to prepare 250 ml 1 molar sodium hydroxide solution, then how would you write this in the question? You have to write 250 in this section ml, and the question was, how would we prepare 250 ml 1 molar, and you have to write 1, and the normal section should be eliminated from this part. You can pen through this n like this, then only the molar part will remain, and the name of the reagent is sodium hydroxide. You may write the chemical formula or actual name, sodium hydroxide solution. So now it is a complete question. How would you prepare 250 ml 1 molar sodium hydroxide solution using method 1 and method 2? And you have to also prepare another reagent. Suppose you have to prepare 100 ml 0.1 normal sulfuric acid solution. Then you have to write, at first you have to complete the question. You are asked to prepare 100 ml, you have to write 100 in this section, 0.1 normal, 0.1 normal, that means you have to eliminate the molar section. You can pen through this molar section, 0.1 normal. Now the molar section is omitted and only the normality will be calculated or considered, and you have to prepare sulfuric acid solution, sulfuric acid solution. Okay, using method 1 and method 2. Now it is the complete question. First question is, how would you prepare 250 ml 1 molar sodium hydroxide solution using method 1 and method 2? The second question is, how would you prepare 100 ml 0.1 normal sulfuric acid solution using method 1 and method 2? So the chemicals and reagents are, for method 1, the chemical and reagents is sodium hydroxide, and for method 2 the chemical and reagent is sulfuric acid. And in case of sulfuric acid, the bottle or reagent bottle will provide you with the purity and the density. There will be indicative of the purity. Generally it is written as assay value. Sodium hydroxide also will have a assay value. sorry, we'll also have a assay value. Assay value indicates generally its purity, and you have to take the lower part. It may be 97 to 101. Then you have to take the 97 percentage. Its purity is 97%, and sulfuric acid has its purity 98%. It is written in the top of the labeling of the bottle, and where 1 liter is 1.3 kg, it is the density. 1 liter is equal to 1.83 kg. That means 1.83 kg per liter. That means 1.83 gram per ml. I have divided the kg with 1000 and liter with 1000. Dividing the kg with 1000 provides you the gram, and dividing the liter with 1000 provides you the ml. So 1.83 gram per ml. That means 1.83 gram in 1 ml. 1 ml. Okay, 1.83 gram in ml. I think it is clear to you how you have to complete the question, and you have to write the name of the chemical reagent. Okay, now let's move on to our mathematical section. You have to write down the complete procedure of the mathematics that is required to prepare this solution, and you have to fill up this mathematical calculation both in your laboratory manual and also in your data sheet. So our first question was for solid reagent. The solid reagent was sodium hydroxide, and our question was preparation of 250 ml 1 molar sodium hydroxide solution. Now we have to fill up this form like this. The molarity or the strength was 1 molar. You have to write 1, and you have to cancel out the normal section by, you can cancel out the normal section by just drive your pen through this normality. And the volume was 250 ml. I have written here 250 ml, and the name of the reagent is sodium hydroxide. Now the reagent is sodium hydroxide. Okay, the next line is that we have to write down the molecular weight of the given solid reagent. In this case, the solid reagent is sodium hydroxide, so we have to write that the molecular weight of sodium hydroxide. Oh, you can write either the chemical formula or write in word. And we know that the molecular formula of sodium hydroxide is 40 gram, approximately 40 gram per mole. And I should mention that you will find this formula along this formula as well as the molecular weight from the container that contains the sodium hydroxide, and from which we should make the actual solution, will provide us with the molecular formula as well as the molecular weight and the assay value. Okay, since we are calculating the molarity, there will be no equivalent weight calculation, but in this regard I would like to show how the equivalent weight is calculated. If it were a normality solution, we have to calculate the equivalent weight, and for sodium hydroxide the equivalent weight would be 40, and 40 divided by 1. 40 is the molecular weight of sodium hydroxide, and 1 is the equivalent weight, equivalent number for sodium hydroxide. 1 is the equivalent number for sodium hydroxide. We know that by dividing the molecular formula by the with the equivalent number, we will get the equivalent weight or equivalent mass. Okay, 40 divided by 1, this will provide us the is equal to 40. That means sodium hydroxide has the same normality and same molarity, since it has the equivalent number 1. This part should have been done if we were calculating we were calculating the normality. Since we are calculating the moderate, we do not have to write this section. Okay, now let's move on the formula for the calculation of molarity of sodium hydroxide, and we are using one of the formulas for the calculation of molarity and normality. There are lots of formula. uh, we can use the traditional formula. By definition, molarity is the moles of solute divided by volume of solution in liter. We can use that formula, but in this regard we will use the formula that states that 1000 ml in this formula. We have to write this thing: 1000 ml 1 molar sodium hydroxide, 1000 ml 1 molar sodium hydroxide is equivalent to 40 gram. 1000 ml 1 m sodium hydroxide is equivalent to 40 gram. The next line, we are writing this formula in elaborately, so we are using 4 lines, but actually you will find that in your laboratory manual you have got only 2 lines, as well as the 2 lines will also be presented in your data sheet, but for better understanding we are writing 4 lines. Okay, now 1 ml 1 molar, same thing, sodium hydroxide is 40 divided by 1000. Since 1 ml is far less than 1000 ml, so it will be a very small unit, so we have to put the 1000 ml in the denominator and 40 in the numerator. Okay, now this line will not be required by us, so we are omitting this line. If we had been calculating 0.1 normal or 0.1 molar, then we would record this line. Since we are calculating a non-function integer numbers, we do not require this line. And the next line will be 250 ml, that is our intended or required volume. 250 ml 1 molar sodium hydroxide sodium hydroxide is equal to the 40. We have calculated the found out the amount or volume required for preparation of 1 ml 1 molar, and now we are calculating for the amount required to prepare 250 ml. 250 ml is apparently very much large volume than 1 ml. So since 250 ml is large, then we have to multiply this upper formula 40 with, this is 1 and this is 250 ml. We have to multiply this one with these things, 250 ml. Since 250 ml is very long formula, very large formula, then we have to multiply this staff with 250 ml, and this one comes from here. Since we are calculating a single unit, we do not need to write this one, but as our formula contains a space in this position, so we have to write just 1 in this position. But if we do not write 1, then still it will be enough for the calculation of this mathematics. Okay, and the answer is 10 gram. Calculating this one, we will find that this is 10 gram. Okay, actually in your laboratory manual you will have only this line and this line. You have to fill up this line, then you have to fill up this line, and you have to fill up this position also. Since integer number, or now a 1, if 1 molar 1 normal is prepared, then this position is not required. If 0.1 normal, 0. Or any other value other than the 1 molar or 1 normal is calculated, then we will require this position. That is why this position has been placed in the formula. As in this case we are preparing just 1 molar, so we since we although we do not need to write 1 here, but as the formula contains space, so to just meet the need of the formula, we are writing 1 in this place, and the result is 10 gram. Okay, now we know that the purity of sodium hydroxide is 97%. The SI value is 97%. That has been seen from the label of the container. So we will write that the purity of sodium hydroxide is 97%. 97%. So since it is a 97% purity, so we can write that thus 97 gram sodium hydroxide is present in 100 gram. 97% purity indicates that 97 gram sodium hydroxide is present in 100 gram. Why? Because sodium hydroxide is a solid reagent and the purity 97% indicates W by W. The percentage 97% indicates W by W. So W by W means the weight of solute in weight of solution, or total weight of solution. Since 97% is the purity of sodium hydroxide, so we have to write that 97 gram of sodium hydroxide is present in 97 gram of sodium hydroxide is present in 100 gram. Therefore we have found that 10 gram our 10 gram will be presented in a different volume. We need just 10 gram of sodium hydroxide for the preparation of 250 ml 1m sodium hydroxide, but since it is 97% pure, so if we take 10 gram from sodium hydroxide, then as it is a 97% pure, we will not get the exact 10 gram of sodium hydroxide by taking just 10 gram from the container. So we have to calculate the exact amount of sodium hydroxide that has to be taken out from the container to ensure that the amount contains exactly 10 gram of sodium hydroxide. So we are calculating this part. So 10 gram of sodium hydroxide is present in 10 in the numerator, 97 in the denominator, 97 in the denominator, 10 in the numerator, and the volume is 10.30 something, 10.30 something. This is the actual volume, actual weight that we have to take from the container that is containing 97% pure sodium hydroxide to get the exact 10 gram of sodium hydroxide. And after taking this 10 gram of sodium hydroxide, we have to put this in the 250 ml beaker, 250 ml volumetric flask, and make the solution by using either method 1 or method 2. So I think you have understood how the mathematical formula for the calculation of a solid reagent is filled up in the laboratory manual as well as in the data sheet. Now let's move on our next reagent, and the next question was for the how you would prepare 100 ml. How would you prepare just 100 ml, sorry, 100 ml, not 100 ml, prepare 0.1 normal, 0.1 normal. So we have to omit the molarity value. You can just fin through this molarity value. 0.1 normal, 100 ml sulfuric acid solution, sulfuric acid solution, sulfuric acid solution. So this is our given mathematics. Preparation of 0.1 normal, molarity has been omitted, 100 ml sulfuric acid solution. Okay. And From the container we can find out the molecular formula as well as the actual molecular weight of the sulfuric acid. Since we have to prepare the solution by taking sulfuric acid from the container, it is very good practice, or it should be done from it should be practiced during the calculation, that you have to find out the actual molecular formula as well as the molecular weight from the labeling of the container. The molecular weight of sulfuric acid is approximately 98 gram per mole, and molecular weight of sulfuric acid is 97.8 point sorry, I have to write out the name of sulfuric acid. Sulfuric acid, since sulfuric acid is our intended reagent, we have to write the name of sulfuric acid. The molecular weight of sulfuric acid is equal to 98 gram per mole. 98 per gram per mole. It is an approximate weight, but the actual weight may contain a fraction, and that will be found in the labeling of the container. Now, since we are calculating for the normality, we have to know the normality, the equivalent weight of sulfuric acid. For the calculation of normality, equivalent weight is very important. So the equivalent weight of sulfuric acid would be molecular weight of sulfuric acid divided by the equivalent number, or number of active mass in the acid base reaction, or equivalent number is 2 of sulfuric acid. This gram per mole sulfuric acid. So an equivalent weight of sulfuric acid is 98 is the molecular weight of sulfuric acid, and 2 is the equivalent number of sulfuric acid. So we have to divide the molecular weight with the equivalent number, and this gives us 49 gram per mole. So 49 gram per mole is the equivalent weight of sulfuric acid. Okay, now let's move on our next section. In this section we will calculate the exact amount required to prepare the sulfuric acid, that means 100 ml 0.1 normal sulfuric acid. So we are using the formula. In this case we would use the 4 lines, but actually we will find only 2 lines in your laboratory manual. This 4 line in this tutorial has been demonstrated for better understanding of the formula. Okay, let's move on. The formula says that 100,000 ml 1 normal sulfuric acid is equivalent to 49 gram. And next line is, we are putting this 1000 ml into 1 unit, so we have to write 1 ml. 1 ml is far less than 1000 ml, so we have to put this 1000 ml in the denominator. 1 ml 1 normal. I am just keeping the normality same as the previous line. 1 ml 1 normal sulfuric acid is equivalent to 1000 ml is equivalent to 49 grams. So 1 ml is equivalent to very smaller amount, will be equivalent to very smaller amount. So we have to divide the 49 gram by 1000 ml. So this is the amount required to prepare 1 ml 1 normal sulfuric acid. 1 ml 1 normal sulfuric acid. Okay, next, since we have to prepare 100 ml, now we will write that thing 100 ml. I am keeping 1 normal in the previous state, 1 normal, I am not changing that. Sulfuric acid is equivalent to, and you can clearly see that 1 ml is very smaller than 1000 ml, so we have to put 1000 ml in the denominator, but 100 ml is much greater than 1 ml, so we have to multiply this whole thing with 100 ml. We have to multiply this whole thing with 100 ml, so we have to multiply 49 with 100 divided by 1000 gram. So this is the amount required to prepare 100 ml 1 normal sulfuric acid. But the question gives us that we have to prepare 1000 ml 0.1 normal. So we are to write in the final in the last line 100 ml 0.1 normal, 0.1 normal. You see that this is the unit, unit normality for sulfuric acid. And you know that after getting the unit normality, you have to multiply the unit normality to increase the or decrease or increase whatever you say with anything that comes other than the unit volume. That means if it is 0.1 normal, you have to multiply the whole thing 49 100 divided by 1000 with 0.1 normal. If it were just one normal, then we do not have to write this line. This line would have been enough for the calculation of 100 ml 1 normal sulfuric acid. But since we have to calculate 100 ml 0.1 normal sulfuric acid, we have to multiply whole of this thing with 0.1 normal. Since this whole thing is for one normal sulfuric acid, that means unit normality of sulfuric acid, and as the volume do not change, so we have to multiply this unit volume with 0.1 normal. If it is other than any volume other than value other than 1, we have to multiply that value. We have to multiply this whole thing with that value if the volume remains the same. If the volume remains the same, then we have to multiply the unit normality of sulfuric acid with that value of normality. If the value of normality of sulfuric acid changes from 1, then we have to multiply this whole thing with the changed value of normality. I think it is clear to you. Let me repeat this again. We have to, the first line of the formula is 1000 ml 1 normal sulfuric acid is equal to 49 gram. The next line we have we have to know what is the what is the amount required to prepare a unit volume of sulfuric acid with the unit normality. So we have reduced the 1000 ml into 1 ml. This is the unit volume of sulfuric acid. This is the unit normality of sulfuric acid. So we have to write that unit volume of sulfuric acid. That means 1 ml 1 normal sulfuric acid requires this amount of sulfuric acid. Okay, the next line we have to write the volume that is given for the calculation of our intended solution, and the volume was given to prepare. We have to prepare 100 ml solution, so we have to write the volume first. The volume is 100 ml, which is mass more greater than the 1 ml. So we will require more sulfuric acid than the 1 ml. That is why we have to multiply the unit volume of unit normality sulfuric acid with 100 gram with 100 ml. In this way, we will find out the amount of sulfuric acid required to prepare 100 ml 1 normal sulfuric acid. Afterwards, we have to calculate the amount required to prepare 0.1 normal sulfuric acid. Since we have found the unit normality and as the volume do not change, so we have to multiply the amount of sulfuric acid with the changed normality other than the 1. If the normality changes other than the 1, we have to just multiply the amount of sulfuric acid with that normality. So yes, we have multiplied this thing with 0.1 normal, and the amount after calculation we obtain is 0.49 gram. So this is the amount of sulfuric acid required to prepare 100 ml 0.1 normal sulfuric acid. But you know that sulfuric acid is not a solid reagent. Sulfuric acid is a liquid reagent, so we are not able to weight 0.49 gram volume acid from a liquid sulfuric acid. So we have to convert this volume, this amount of sulfuric acid into volume. That means we have to convert this gram into ml, and to do so, we have to take a look. The sulfuric acid, the purity of sulfuric acid was 98%, that means 98 gram sulfuric acid is present in 100 gram. And there was also another information that 1 liter of sulfuric acid is equal to 1.3 kg sulfuric acid. That means 1.3 gram 1.83 gram per ml. That means 1.83 gram sulfuric acid in 1 ml. 1.83 gram sulfuric acid in 1 ml, which have been derived from this formula. Since 1 liter contains 1.83 kg, so 1.83 kg is present in 1 liter. And conversely, we can say that 1.83 gram is present in 1 ml. We can obtain this gram by dividing the kg with 1000, and we can obtain ml by dividing the liter by 1000. So it is very easy formula. So from this equation, from this information, we can write that 1.83 gram sulfuric acid is present in 1 ml sulfuric acid solution. Okay, now let's write this thing, that since the density of the surplus solution is 1.83 kg per liter, which is equivalent to or equal to 1.83 gram per ml, that means 1.83 gram of sulfuric acid is present in 1.8 gram of sulfuric acid is present in 1 ml sulfuric acid solution. 1 ml sulfuric acid solution. So 1.83 gram of sulfuric acid is present in 1 ml sulfuric acid solution. So 100 gram, what will be the amount of 100 gram? 100 gram of sulfuric acid will be presented in sorry, that uppercase, that was uppercase, is present in 1.83. We have omitted one line. 1.83 gram of sulfuric acid is present in 1 ml. That is why 1 gram of sulfuric acid is present in 1 divided by 1.83 ml of sulfuric acid, and the third line will be 100 gram of sulfuric acid is present in 1 into 100 divided by 1.83. It is very simple formula, so we have omitted the third line. That means the middle line between the first and last line, and this gives us 54.645. This is the equivalent weight of 100 gram sulfuric acid. That means we can say that 1.8 gram of sulfuric acid is equal to 1 ml. That is why 100 gram of sulfuric acid is equal to 54.654 ml. 100 gram of sulfuric acid is equal to 54.654 ml. Okay, now since the purity of sulfuric acid was 98%, the purity of sulfuric acid was 98%, the purity of sulfuric acid is 98%. That means it is a weight per weight solution. Weight per weight solution means 98 gram sulfuric acid is present in 100 gram. Since the purity is 98%, so we can say that 98 gram sulfuric acid is present in 100 gram, and previously we have calculated that 100 gram of sulfuric acid, in this case 100 gram of sulfuric acid was equal to 54.654 645 ml. So we can write that 98 gram of sulfuric acid is present in 100 gram of sulfuric acid, since it is 98% pure, and 100 gram of sulfuric acid is equivalent to or equal to 54.654 ml. So we can write that 98 gram sulfuric acid is present in 54.654 ml. And we have found that from this line we can find out the volume of sulfuric acid required. That means this line will convert the gram into ml. This line has already converted the gram into ml, and we have to convert 0.49. We have found that for the preparation of 100 ml 0.1 normal sulfuric acid, we need just 49 gram of sulfuric acid. So we are now converting this 49 gram sulfuric acid into ml. 100 ml 0.1 normal sulfuric acid, we have to write this name sulfuric acid in here also. In this case you have to write the name sulfuric acid, that was mistakenly not written here. Sulfuric acid. Okay. This completes our formula. So it is clear from this that we have to weigh out 49 gram sulfuric acid and dissolve this 49 gram sulfuric acid in 100 ml, and this will produce 0.1 normal sulfuric acid. But the actual problem is that sulfuric acid is not solid, it is a liquid. So we have to convert this 49 gram sulfuric acid into volume. We have to find out what volume of sulfuric acid is equivalent to 0.49 gram sulfuric acid. For this calculation we have already converted gram into ml, and we have found that 100 gram of sulfuric acid is equivalent to 54.654 ml sulfuric acid, 55.654 sulfuric acid. So 98 gram sulfuric, since sulfuric acid is 98% pure, so we can say that 98 gram sulfuric acid is present in 100 gram sulfuric acid, and 100 gram sulfuric acid is equal to 54.654 ml sulfuric acid. Now we are writing the intended volume. 0.49 gram sulfuric acid is present in 54.645 multiplied by 0.49 divided by 98 it is the formula for the calculation of the amount of sulfuric acid required to prepare intended volume of sulfuric acid, and the volume is 0.273 ml. So we have finally converted the gram into ml, and the purity has also been taken into account. Now we have to take 0.273 ml sulfuric acid from the container that holds the sulfuric acid and dissolve this 273 ml sulfuric acid in 100 ml volumetric flask. That will provide us our intended 0.1 normal sulfuric acid. That's all about the calculation, mathematical formula, as well as forming of the laboratory manual, as well as the data sheet for liquid and solid reagents. So we have understood the whole process. Thanks to all for watching.